So good morning, dear students. Am I audible?
Yes, sir.
Thank you, Chandrasekhar, for the confirmation. So let us not waste our time. Quickly start today's class and do the revision of first module, so that the first module you can prepare well for the upcoming internals. So today we discuss about spanning tree algorithms in bridge lands. So this is the topic that we are supposed to discuss. Quickly, yesterday what we have discussed. So bridge is nothing but it is interconnection of two lands. So bridge LAN is also bridges are also called as LAN switches. So generally they connect two LANs, so that one LAN will be extended in another LAN. So that's what yesterday we discussed. So two local area networks can be connected using LAN. And remember, there is a limitation for each LAN. There is 1,000, 24, mm, nodes are limited for each LAN. So beyond that, if you want to have extension, so certainly you have to use a bridge and you can extend. When you use a bridge like this and extend, what happens? Each bridge maintains a forwarding table like this. So this forwarding table helps them to either to forward from one port to another port. So not all the packets, all the packets will not be transmitted from one port to another port. Only if the destination is present in other port, so the bridge will transmit, or else it will be transmitted inside one LAN itself. If the destination and source are present in the same LAN, it will never forward it. So that's what we have to understand. And this entire thing, that's what bridges will learn as they boot. The table will be empty, and it will send echo packets. So echo packets hit each system and come back, and with that, so your bridge will come to know, or LAN switch will come to know, or port number one, so many computers are there. Port number two, so many computers are there. It will prepare a table. So this table will be always referred before forwarding from one port to another port. If the source and destination are present in the same LAN, so packets will not be transmitted. If they are in two different LANs, then packets are transmitted. So that's idea about it. And till yesterday, whatever we have seen, this particular LAN setup is so simple, so simple LAN. If you look at the complicated LAN like this, so what happens? There are loops. Loops means, I think probably in graph theory you might have studied. Loop is nothing but it's a closed walk. That means if A sends a packet to say for example H, so what happens? A to C, B. So packets will roam in the same circle, keep on roaming in the circle. Circle itself, it will be roaming. So this creates a sort of problem in the network. If there is a closed network like this, so circular, LAN, so definitely there is a problem. So how to overcome this kind of problem is what we have to understand. For this, the preceding, whatever we have discussed so far, what's very fine until an extended LAN has a loop. Loop means uh, closed network. So in which case it fails horribly, the frames potentiality, loop through the extended LAN forever, and it will never reach the destination. It will keep on looping. So it creates a traffic jam, it creates congestion, it creates of course the packets will never go to the destination. So that is the biggest problem that we have with respect to this, looped, complicated lands. So, what is the solution for this? And of course, it is easy to see that in the example depicted in the figure, uh, for you know B1, B4, B6, B1, B4, and B6. Look at this diagram. So they form a loop. They form a loop, and when they form a loop, so what happens? It creates a problem. Similarly, B1, B2, B3, B5 creates a loop. So it is a biggest problem. So, and even B1, B5, B7 forms a loop. So when there are looped systems like this, extended lands like this, it becomes a problem. How to overcome this? So suppose you have a packet, another case, you have a packet from B4. So B4, that is J is here. Yes, exactly. You can see J is present here, J, and J is attached to B4. And from J, what happens? You are trying to Ethernet from J. So what happens from Ethernet J, and the destination is addressed, is not at in the bridge, and it is forwarding table. So in this case, what happens? B4 sends a copy to the H, and from H, what happens? H to I, and of course, so now bridge 6 forwards the Ethernet to G, where B1 would see the forwarding back to the Ethernet H, and B1, B4 will still doesn't have this destination in this table. So forwards the packet back to the Ethernet IJ. So what happens? It will be, keep on looping. So IJ and HIJG. So all these certainly keeps on, the packets will keeps on looping. So that is another, and there is nothing to stop the cycle from repeating endless. There is no end. The packets will be looping both in the direction, clockwise direction as well as in the anti-clockwise direction. B1, B4, B6, B6, B4, B1. So it will be keep on looping. So what is the solution? What is the solution for this kind of complicated lands? When you design complicated extended lands like this, you will face this looping problem. And what is the solution for this looping problem is the next. The solution is very simple. You have to create what you call it as spanning tree. So you have to create a spanning tree. That is the only solution that you should hold. So you can see bridges must be able to correctly handle the loops. This problem is addressed by having the bridge to run distributed spanning tree algorithm. Distributed spanning tree algorithm. The distributed spanning tree algorithm is one. If you apply this, what happens? Look at this example, one example. You have a network like this, similar. So all the nodes has to be selected in such a way that they should have only one path. You should always have only one path. So if it is covered with all the nodes with only one path taking, so that we call it as a spanning tree. So this same thing, this is the original one based on this the corresponding spanning tree. So the path between each and every node is connected by only one path. If you do like that, like a spanning tree, this is spanning tree. So what happens? Your problem will be solved off. So the looping problem will be solved. The same thing you can see. If you think of an extended LAN as being represented by a graph, that possibly has loops, that is in cycles. Then the spanning tree is a subgraph of the graph that covers all the vertices, but that has only one path with no cycles. One path with no cycles, right? And that is a spanning tree keeps all of the vertices of the original graph, but throws out some of the throws out some of the edges. For example, in the figure, this 3.1, so some of the edges are not been considered. So if you consider that, a loop will be creating. So a loop will create a problem. So in order to avoid loop, some of the edges are taken off. So by doing so, you can achieve spanning tree. If you achieve spanning tree, the looping problem is solved, and of course the packets can easily forward from one location to another location. Here, look at here, the dotted lines are to be removed off in order to get your total get your total what do you call uh, mm, loop free extended LAN. So the same thing you can see there. So in practice, each node decide the port over which it is, and it is not willing to forward the frame. So everybody should plan. Of course, every bridge has to plan in such a way that whether I should forward in this line. If I forward in this line, there should be a loop. There will create a loop. So better to avoid the loop. That link, even though it is present, it will be disabled. And so that by doing in that such sense, it is by disabling that particular port on the topology, that the extended LAN is reducing the cycles that will create an acyclic graph or acyclic tree. So the LAN becomes cycle-free, cycle-free LAN. So that is how it has to happen. The algorithm is dynamic in the sense. However, the algorithm will run on all the bridges, and when it runs on all the bridges, so spanning tree algorithm, when it runs on all the bridges, so what happens? So you can avoid the looping. So sometimes what happens, networks may come up, bridges may come up dynamically. When the bridges come dynamically up and down, some goes down, goes up. So every time when a bridge comes up and goes down, so what happens, this algorithm has to run, spanning tree algorithm has to run, and make sure that the entire LAN is acyclic. Acyclic means without any loop, without any cycles. So cycles in the sense loops. So this algorithm is a dynamic, however, meaning that the bridges are always prepared for reconfigure themselves into a new spanning tree should some bridge fail. And so those unused ports and bridges provide the redundant capacity needed to recover from failure. So this is how you can certainly achieve, what do you call, acyclic, lands, so that you will not have any problem. So this is one very important question. Exams, they will be asking a lot of time. Meanwhile, in the next class, we'll discuss about the basics of internet working. Basics of internet networking we'll discuss. Now, I have few announcements to make. So I have already prepared an assignment. So you can see I have prepared an assignment. This assignment has to be handwritten. So last date for writing the assignment for module 1 is 29th April, that is on next Thursday. So I have given 1 week time. Next Thursday you will be having a test also, internal test. And of course, before that, if you write, definitely your preparation and writing this assignment will be hand in hand. It will help you. So that is my intention. Originality of the answers are well appreciated. Answer to assignment should be written only in hand. So prepare well, write down legibly, neatly on a book. On this book, you have to submit once you report back to the college. So, and using CamScan or similar apps, you can convert this entire book, whatever the pages that you have written, into a PDF file. And note, very important, whenever you, while writing your answers, you write in black pen, so that when you scan, you will have better visibility. And if you write in blue light pen, so you will not have good visibility. Once the PDF file is done, so this PDF file you have to upload it in this. And remember, across every page of your assignment, write the USN, write your name, and write the page number. So, and the assignment should be submitted by 29th. For this assignment, you will have 30 marks, and this marks or grade will be announced after the internal. So if you submit it before 29th, it will be considered for internal assessment. And of course, it is an instruction, we have got it from VTU. So you can take assignments like this, and also we'll conduct online tests. I have given only 5 questions. So you have to write answer to these 5 questions. And every question you have to start in a new page. That's all. So question number 1 in page number 1, maybe, or 1 or 2, 3. So if you're writing second question, you start it in a fresh page. Third question, fourth question, fifth question. I have only 5 questions given, and you prepare well. Your exam, internal exam, will be multiple choice questions. And make sure that this assignment you write in detail, so that after the verification, this book, assignment book, will be given to you back. So this will definitely help you to get your good marks in the examination. So this becomes a question bank kind of thing, module wise important question bank. So it will help you a lot more. So that's the concept about the assignments. I think I have already shared with Chandrasekhar, your CR. He will send all these questions and instructions shortly in your group. Moving to further, yesterday revision. Yesterday we were discussing about the multiplexing, statistical multiplexing. So in statistical multiplexing, if you don't have uh, packet in that particular slot, what happens? It will be continued, and no slot in the statistical time division frame quanta is left blank. So this is been followed even today in most of the technologies. So most of the technologies, communication technology and other things. And support for common services. Support for common services. If 2 applications are there, so your abstract network, we call it as cloud, it should support it. Manageability, you have to design in design the website, or sorry, network, in such a way that they should be easily manageable. Next, classification of computers. When we look into the classification of computers, based on the size of the network, we'll classify into personal area network. Personal area network, it is between 2 computers or 2 devices. So maybe Bluetooth, using Bluetooth, you can connect to different networks. Using RFID, you can create 2 networks. Using Wi-Fi, microwaves, you can create 2 networks. So best example is your share it with to share it. You can connect your laptop with the 2 laptops, or 2 mobile phones, or mobile phone with laptop, you can certainly connect. LAN, of course, local area network, so which is fixed, working in geographical area. It can connect, of course, up to 500 meters, and advantages. So easy to use. Disadvantages, you cannot certainly go beyond your limit. Next is within the city, if you want to create a network, it is called a metropolitan area network. So normally central office to branch office, regional office, factory, and warehouse. If you want to create a set of network, so it is also possible within the city. Interconnection, normally it will be done through the radio waves. It will be done through radio waves. The disadvantages, security mean, and it is very costly. Example, WiMAX and cable TV certainly we have. The third one is wide area network. Wide area network where you can connect to very distant places using satellite phones, satellite devices. We can connect. So advantages are there. A lot of advantages compared to disadvantages. Example is internet. Internet, through internet we are connecting to various people, across various wide geographical range. Next one is storage area network. This is exactly a network mainly used for storing the data, especially today in the IT world, when people are using Facebook, WhatsApp, and other thing. The data is huge data, big data. So big data handling, you cannot store it in one computer. You have to store it in multiple computers. So in order to store in multiple computers, definitely you should require storage area network. We call it as SAN. So it is for just storage. Moving further, we have network architecture. So the entire network operations can be, split into, you know, two different models. One is OSI model, another one is internet model. Internet model is also called as TCP/IP model. It is also called as TCP/IP model, and OSI model has 7 layers. So application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. Mainly physical layer is responsible for connecting, physical, physical connections are done with this layer. And observe, of course, translation of bits into encoded signals, carry data in terms of zeros and ones. So that will be done in this particular layer. And it is mainly helpful in transmitting the data bits through what do you call it as um, through physical medium. And of course, examples: Ethernet, FDDI, V.24, etc., RJ45, etc. Data link layer main job is to check for, organize the frames, create the frames, create and detect frame boundaries, handle errors, so implement the flow control, and also support for point-to-point network, simplex network, full duplex network, broadcast network, as well as the various other networks like media access control, etc. The next layer is network layer. Network layer mainly responsible for maintaining the network. So to move the packets from source to destination to provide internet working. Of course, define the most optimum path. So in order to find the most optimum path, so shortest path, very good path. So what happens? Network layer will play a very important role. Network layer also defines the logical address so that at any endpoint can be identified. It will also, handles the, congestion. And network layer also defines uh, how to fragment a packet into smaller packet to accommodate different medias. So that is also another job of this one. So normally the datagrams are being used here in network layer, because in data link layer the datagrams are called frames. And In transport layer provides process-to-process message delivery and error recovery. Of course, the purpose of this layer is to provide reliable transmission of exchange of data between two processes in different computers. It will ensure that data units are delivered error-free. Data units are delivered in sequence. No loss or no duplication of data units are being handled. It provides options for both connection oriented. There is before transmitting, connection has to be established. Connectionless, no prior connection is required. As you move, automatically the intermediate switches will show you the path, and you can reach the destination. So that is how certainly it works. The unit of communication in transport layer is user datagram as well as the packet, depending on the specific protocols. Session layer, it is mainly used to establish, manage, terminate sessions, and session layers also provide a mechanism for controlling the conversation or the dialogues between two computers. It will create a what do you call session. It will create a session between two, starting of the transmission to the ending of the transmission. The entire process, we call it as a session, and the session will be taken care. This layer requests for logical connection establishment of the user. Of course, this will be session layer will be mainly helpful in doing transactions. Whenever you are buying something, doing bank transaction, or transferring money, so this session layer has to be. So when you make the entire process as a session, what happens? It is a sort of protection that you have, so that your data or your transaction cannot be tampered or you know uh, what do you call denied. So somebody cannot hack. So this presentation layer is a layer that normally encrypts the data, compresses the data, presents the data in the format in which the data is to be exchanged between two communication entities. Also handles data compression and also data encryption and decryption, just for the safety and security. So application layer, to allow the access to the network resources, to access network resources, and application layer interacts with the application program, and of course the higher level of OSI model. Application layer contains management functions to support various applications, distributed application. Examples of application layer are, your file transfer, electronic mail, email, remote login, your, internet. So those are all examples of your application layer applications. The drawback of OSI model is it is too loosely coupled, defined, and proprietary standards were too entrant, and it is not even tangible. OSI model does not do any function in the network process. So in order to overcome all these things, we have another network model architecture called TCP/IP model, or we call it as internet model. Even today, this internet model it has been used, and it is having only 4 layers. Remember, so your application layer, it is performing the operations of both application layer, presentation layer, and session layer. Whereas transport layer is doing the same operations of transport layer. You have another layer called internet layer. So this internet layer is going to perform network, whatever the network layer in OSI model used to do, same operations your internet layer used to. The last one is link layer. It is also called host to network layer. Host to network layer performs the same operation asset of data link layer and physical layer. So whatever the duties that they were doing, so basically they do it. It is basic communication language or protocol on the internet. The TCP/IP provides end-to-end connectivity, specifying how data should be formatted, addressed, transmitted, routed, and received at the destination. The protocol exists for a variety of different types of communication services between the computers. And of course, you can see the functionality of each layer in internet is application layer. Application layer is useful work with the various applications. Example: HTTP, SMTP, POP, post office protocol. Ping is one. FTP is one. Protocol. And transport layer mainly used for flow control of information between application programs running on the client and the applications running on the server. So example is UDP and TCP. These are the two transport layer protocols. We have internet layer protocol mainly responsible for routing the packets between the computers. We call it as internetworks. So inter means many networks. The protocol running here is IP, Internet Protocol. The subnet layer is also called network access layer. Move the data within the network. So that is Ethernet protocol it is using. Define the physical characteristics of communication and hardware. Physical, communication in the sense of what should be the bandwidth, what should be the thickness, what should be the length, what should be the error detection method that it has to follow, what are the various mm, physical properties that we can use. So maybe radio waves, twisted pairs, fiber optics. These are all some of the examples of this particular layer. Same thing it has been given. So what is that layer doing in detail? We have just explained about all these things. And there are questions where they are certainly asked three features of internet architecture. So with this three features, only uh, even today, internet architecture it is used in network. First one is as the best illustrated in the previous figure, internet architecture does not imply strict layering. There is no strict layering. Look at there. So there is no strict layering in this particular diagram. Submission, subnet layer can talk to application layer. IP can talk to application layer. TCP, UDP can talk to application layer. So there is no such thing. There is no uh, strict rules. And remember, many networks will certainly come to internet layer, and internet layer will certainly talk about a transport layer. And of course, transport layer has many protocols running in the application layer. So that can be easily done. And of course, the second feature is that if you look at closely the protocol graph in the figure that we have shown already, we will notice that it is working like an hourglass. Wide on the top, that means variety of application protocols are present on the top, and in the middle, narrow in the middle. So narrow in the sense your IP model, certain IP internet, layer. Internet layer will certainly have only handling the transportation among the various networks, and of course, so it will handle wide variety of networks. It defines the common method for exchanging packets among the wide collection of networks. So look at this diagram again. So look at here. So you have various types of networks, but the focal point is IP. IP will connect to various networks, and finally it will connect through transport layer. It will talk to your application layer. So this is most common. that is the second good thing about this. So, and finally, the final attribute of this internet architecture is it is more accurately defined by IETF, Internet Engineering Task Force. So it is one of the organization that certainly standard gives the standards. So in order to create a new protocols officially, you can certainly create, take permission from ITF and you can create. Whereas in the case of OSI model is a Cisco model. You cannot have any ownership. So it is an open source model. TCP/IP model or internet model is open source. Anybody can write, anybody can do protocoling, create, do, and enhance. So, last and foremost thing about today's class is comparison between OSI model and TCP/IP model. So there are some similarities. So you have to identify some similarities, and you are supposed to write the differences also. So one of the similarity is OSI and TCP reference models have much in common. Both are based on the concept of stack of independent protocols. Also, functionally, layers are roughly similar, but in both the models, layers up through including the transport layer are the common one, transport layer, and network layer. Here, network layer is internet layer. Both performs the same operation. Coming on to their differences. So OSI is 7 layer, TCP is 4 layer. Transport layer guarantees the delivery. Here also transport layer guarantees the delivery of the packet. Separate presentation layer is there. Separate session layer is there. There is no presentation layer, separate session layer. Everything is characterized by your application layer itself. And coming on to the next one, network layer provides both connectionless and connection-oriented services in OSI, but network layer only provides connectionless service. No clear distribution between the services and interfaces, but it defines the strict rules in OSI. There is a strict rule, and the seventh one, the protocol is better in better hidden and can be easily replaced with the technology changes, but it is not easy to replace any protocol. TCP/IP cannot be used for any other applications, and of course this model does not fit to any protocol stack. So it is what you call it as so all the protocols that are written for specific application will run for only specific applications. So these are the differences between TCP/IP model and OSI model. In the next class, we'll see some more concepts of the revision, and finally, we'll complete by tomorrow all the revision part of module 1. So meanwhile, everybody, you should start working on the assignments, because all the teachers will be giving assignments. So my assignment, if you spend daily 1 hour, I think within 2 days, 2 to 3 hours are sufficient. You can easily complete it. That's all for today's class. Have a nice day. Thank you for attending my class. Have a wonderful day.